In today's note, we are going to be looking at quadratics, and specifically we're going to be looking at graphing quadratics using a table of values. So we should remember a little bit about quadratics, or hopefully remember a little bit from grade 10, but essentially a quadratic is another type of relationship. We should be familiar with linear relationships or straight lines, but quadratics are looking at more curved lines, or specifically what we call a parabola. And what we're going to focus on is just some introductory stuff, just to kind of get us refreshed with the idea of quadratics. And we're going to go through and we are going to graph them based on the table of values. So here I've picked up some different x values. So we go from -3 to +3. Our y value, we have an equation as our quadratic, the y equals x squared. So the x squared, or that exponent 2, is the key thing that makes this a quadratic. And we'll be looking at some other key characteristics as we go through this unit. So to figure out what the y value is, all you're doing is you're subbing this x value into this equation. So y equals -3 squared, and then you're just going to solve, which -3 squared is 9. Do the same thing for the next one. Plug in -2 for x, so -2 squared is 4. -1 squared is 1. 0 squared is 0. So when you're given an equation, this is how you can fill out the table of values. Plug your point into the equation, or plug the value into the equation and solve. So 1 squared is 1, 2 squared is 4, 3 squared is 9. And those are our values. One key thing, going back up to this first one up here, that -3 squared, if you're using this on your calculator, make sure you include brackets. Or, if you don't, just understand that anytime you square a number, you're multiplying it by itself. So if you have a negative multiplied by a negative, you should end up with a positive. So here, just remember, use brackets. If you're using a calculator and you don't use brackets, there's a chance that you could end up with a negative number because the calculator is assuming that negative is not part of that squared. So now that I have my points, I can go through and I can plot those points. Remember, x and y is just a coordinate, so each row is a coordinate. So -3 and 9, I'm going to put a point there. -2 and 4. -1 and 1, 0 and 0, 1 and 1, 2 and 4, 3 and 9. And I can connect all of these points, and this is going to form my quadratic, or what we call a parabola. So a parabola, remember, is this U shape, or basically the form that the quadratic takes. Going back to our table of values, it also has columns for our first and second differences. So when we're calculating these, this is where we do the bottom minus the top. So in this case, 4 minus 9, we have -5. You could also think of it as the change in y. What are the y values changing by as we go from one to the other? In this case, they go down by 5. In the next one, 1 minus 4 is -3, so we go down by 3. From 1 to 0, or 0 minus 1, we have -1, so we're going down. 0 to 1, or 1 minus 0 equals 1. 4 minus 1, or from 1 to 4, we're changing +3. And from 4 to 9, the change of +5. Looking at this, we can see that all of the values are not the same in our first differences. And this is key because if they were the same in the first differences, it would be linear, right? So that's going back to grade 9. If the first differences are the same, it's linear. But in this case, they're not, so it's not linear, which is good because we can already tell that from the graph. If we go on to our second differences, so do the same idea, but we're looking at this next column. So -3, what's the change from -5 to -3, or -3 minus -5? equals -2. Oh, sorry, no, I have these backwards. -5 to -3 is -2. From -3 oh, sorry, I had it right the first time. My mistake. -3 minus -5, it's a change of 2. -1 minus -3 is a change of 2. 1 minus -1 is a change of 2. 3 minus 1 is a change of 2. 5 minus 3 is a change of 2. In this case, all of our first differences are the same, or sorry, second differences. And this is key for quadratics. So if our second differences are the same, then it's considered a quadratic. So looking at a table of values, if I didn't want to graph it, I can look at the second differences, and that will tell me if it's quadratic or not. Some other key things we want to get out of this graph. This parabola opens, in this case it opens up. And it opens up because this opening here is going up. So it opens up, has a vertex of 0, 0. And if we don't remember what the vertex is kind of that lowest point, or where it shifts direction. So here we're going down, then we shift and we're going up. So that's our vertex there, 0, 0. And lastly, our steps. So how we figure out our steps is how much we go up by to every point. And if I look at this, I go up 1 to the 1 point. The next one I go up 1 again. Or not up 1, I go up 3, and go over, and I go up 5. So here my steps are 1, 3, 5. So those are what we consider our steps. You may also see it as jumps. Example B, same idea, just a different equation. So here if we're going to plug it in, -3 squared minus 2 should get 7. -2 squared minus 2 is 2. -1 squared minus 2 is -1. 0 squared minus 2 is -2. And so on. So again, -1, 2, and 7. With these values now, we can plot those points. So at -3, we're at 7. 2, we're at 2. 1, we're at -1. 0, -2. And then it repeats on the other side. We can connect our points if we want, and here we have our parabola. Just to double check, right, we can go through and look at the first differences. So 2 minus 7 is -5. -1 minus 2 is -3. -2 minus -1 is -1. -1 minus -2 is 1. 2 minus -1 is 3. 7 minus 2 is 5. For the second differences, again, we can do the same thing. -3 minus -5 is 2. -1 minus -3 is 2. 2, 2, and 2. So again, our second differences are all the same. So that's just confirming for us that it is quadratic, and we can also get that from our graph. The parabola in this case opens up because again, that opening goes up. It has a vertex now of, our lowest point has shifted a little bit, so we have a lowest point of 0, -2. And we have steps of, again, same thing. If we go over 1, our first step is 1. We go over 1 again, our next step is 3. Go over 1, our next step is 5. So 1, 3, 5 is still our steps. Again, going through the same idea, just a new equation. So same steps. So -3 minus 3 squared. So -3 minus 3 is -6. And squared is 36. -2 minus 3 squared is so -2 minus -3, or -2 minus 3 is -5, squared is 25. -1 minus 3 squared is 16. 0 minus 3 is, and then squared is 9. Then we have 4, 1, 0. So again, just going through those steps, plug the number into the equation and solve. First differences, again, same idea that we've been looking at so far. What's the change as we go from one to another? So from 25, or from 36 to 25, we go down by 11. From 25 to 16, we go down by 9. We go down by 7. We go down by 5. Go down by 3. We go down by 1. Our second differences, again, subtract, or were we changing by, and we're changing by, or we're increasing by 2 every time. So as we go from -11 to -9, it's an increase of 2, and so on and so on and so on. So again, our first differences are all the same, which means that our second differences are all the same, which means that it's quadratic. I can go and start to plug in my points. In this case, actually, I won't be able to plug in some of them just because they don't fit on my graph, but I can do 0 and 9, and I can do 1 and 4, 2 and 1, 3 and 0. And if I look at my graph, I can kind of already see how it's going to finish off on the other side. Right? If we look back at our last two, they are always symmetrical or the same on the other side. So if I wanted to, I can assume what the other points are by seeing their kind of pair on the other side. And that is our parabola. So in this case, the parabola opens, again, it opens up because this opening is going up. It has a vertex of, in this case, the lowest point is at 3, 0. And it has steps of, again, the same thing. If I look at the one step over and going up, it's a step up of 1. The next one is a step up of 3. The next one is a step up of 5. So the steps are still 1, 3, 5. For our last example, again, still plugging in the information. So if we have -2 times -3 squared, we get -18. -2 times -2 squared, we get -8. -2 times -1 squared, we get -2. We have 0, -2, -8, -18. So again, plug the x value into the equation up here and solve for y. Our first difference is, if we go through, see what the change is. Here we're increasing by 10, increasing by 6, by 2. Now we're decreasing by 2, decreasing by 6, decreasing by 10. Our second difference is, what are we changing by? Well, we're going down by 4. We're going down by 4. Down by 4, down by 4, and down by 4 again. Or you can do 6 minus 10. negative 4. 2 minus 6, negative 4. Negative 6 minus 2, negative 4, and so on. I can now see that my second differences are all the same, so it has to be a quadratic. I can also go and plot my points. Some of them I won't be able to plot just based on the scale, but I can start at negative 2, so negative 2, negative 8, negative 1, negative 2, 0 and 0, 1 and negative 2, 2 and negative 8. And there's my parabola. In this case, my parabola opens down because we can see now that the opening is facing down. It has a vertex of still the lowest or highest point. In this case, it is now 0, 0. And the steps in this case, if I go over 1, I go down 2. So my first step is minus 2, or it's a step down of 2. The next one, I go over 1, down 6, or minus 6. And the next one, if we went over 1 again, from negative 8, we go down. The next one is at minus 18. So now we go down 10. So that is our steps. So in general, if we have an equation of a quadratic, and this is our general form, or what we call the vertex form, which we'll be looking at first. This general form, the step pattern follows 1a, 3a, 5a, 7a, or basically 1 times the a value is our first step, up or down, then 3 times the a value, and so on. So for example, if a was equal to 4, our step pattern would be 1 times 4 for our first step, 3 times 4 for our second step, 5 times 4 for our third step, and 7 times 4 for our fourth step, and so on. So our step pattern would actually be 4, 12, 20, and 28. So basically what it's saying is that for my from one point, I would go over 1, and then I'd have to step up 4 to my next point. Go over 1 again, step up 12 to my next point, and so on. But again, the main thing here is just being able to use a table of values to graph a quadratic. Find the first and second differences to verify that it's a quadratic by checking the second differences, and just a little bit of understanding of what the opening means, so opening up or down, finding out where the vertex is, and determining what your steps are.